In all the decisions I have made in my public life, I have always tried to do what was best for the nation. Throughout the long and difficult period of Watergate, I have felt it was my duty to persevere.
Section 4.3, binomial distribution. Okay, this one says, suppose you play a game that you can only either win or lose. The probability that you win any game is 55%. The probability that you lose is 45%. Each game you play is independent. Alright, part A, if you play a game 10 times, the function describes the probability that you win 7 of those 10 times. Here outlining that we do have a binomial experiment. In this case, the game is played 10 times. If you win, that has a 55% probability, denoted 0.55. If you lose, that is the complement of that, 0.45. Again, the sum of those P and Q always needs to be equal to 1, verified here. They are independent as stated above. Here in that last sentence there, where it says that each has to be independent. And usually games of chance are that way. And then down here for step 4, it's here 0 up to n. 0 represents that you didn't win any of those 10, and then 10 represents that you won all 10. For that together, we've come up with a PDF, and again, like the P plus Q is equal to 1, so the sum of those probabilities also has to be equal to 1 as well, verifying that as a PDF. Then in this case, the GeoGebra calculator will do that for us. All we have to do is change the parameters here from the last problem I did. N is equal to 10, and the probability of success is 55%, 0.55. There, done, and that's it. I'm not doing anything down here for right now. And here's the PDF there, verified. I placed over here for these answers, 0.0003 all the way down to 0.0025. Okay, if you play the game 10 times, the function describes the probability that you win only 7. If you have a case there with use of the word only, then you're going to use the bracket, the double bracket here, just to pinpoint at that one spot. I'll try that again. And it's not working. There it is. Okay. So you can change it to 7, back to 7 there. And it's still not locking in on that. I'll try to fix that. This calculator is not working. Let me go ahead and try to reload that. Sometimes it does happen with, let me go back here and choose back to binomial. Try that again. Okay, so we have 10 tries there. 55% is the probability that we win. Okay, 7, 7. Still won't do it. That's a problem. Yeah, we'll do it. Well, it's never done that before. Frustrating. Oh, there it goes. It's about time. Oh, wow. And pinpoint that. Okay, so if it does work out great, then we'll go ahead, grab the double bracket there, and then place 7 for both, and pinpoints that as 7. You don't really need to do that anyway, just want to show you that it can happen, sometimes a little finicky. But here, just kind of point out here that the probability at 7, the 0.1665 is the probability if you have only 7 wins out of the 10 attempts there. For part B, play the game 10 times. How many do you expect to win? Mathematical expectation there. They're talking about finding the mean. What is the mean number of wins there? So you take the number of attempts times the probability of success, n times p is always be the number of wins. We want to round to 1 decimal place because we have discrete data. Again, our data is the number of wins. Here, any possible values between 0 all the way to 10. Down there at the bottom, what is part C? What is the standard deviation? And then just iterate these things. You folks need to look up there for mu and sigma. The formulas there in the book for binomial experiment. No reason for me to necessarily just write these down, but mu is n times p, and then sigma is the square root of n times p times q. So those are readily available. Looking at those formulas for that section, this section on a binomial experiment. So we'll take the square root of n, which is the 10 attempts, times p, 0.55. Again, going back over those given from the prompt here at the top, p and q. And you multiply that times q there. Take the square root, round to 1 place, again because you have whole data, 1.6 wins.